Hello everyone, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. So this is our channel name, Mathematical Side Trips. I am Napoleon A. Gaking Jr. In this video, discussion will focus on construction of simplification expressions involving irrational numbers of the form square root of a plus or minus b times the square root of z plus or minus square root of c minus plus d times the square root of z. In the preceding video, numbers of the form square root of x plus or minus y, square root of z, plus or minus square root of x minus plus y times square root of z were discussed, their construction and their simplification. Note that the two radicands x plus or minus y square root of z and x minus plus y square root of z are simply conjugates of each other. They are conjugate or irrational numbers. This time we consider the case in which they are not conjugates of each other. So we have the irrational numbers of the form square root of a plus or minus b times the square root of z plus or minus square root of z minus or plus d times the square root of z. Simplification problems of this form have also appeared in many mathematics competitions. Let us first look at some numbers of this form under simplification. So we have two numbers here. So this is how they are simplified. Okay, so the technique is to write the integer part as the sum of a perfect square and a square multiple of the second radicand. The second radicand here is 3. So 1, 4, 9, 16, 25, and 36 are perfect squares smaller than 37. So among these choices, the correct numbers that should be added are 25 and 12, because 12 should be a square multiple of the second radicand. The second radicand here is 3, and 12 is 4 times 3. So 4 is a perfect square, and therefore 37 should be written as 25 plus 12, not 1 plus 36 or 4 plus 33 or 16 plus 21 and other choices, no? 36 plus 1. Okay, I already mentioned that. So, and this number, 25 plus 12 minus 20 times the square root of 3, is actually the square of the number 5 minus 2 times the square root of 3. And since the square root and the squaring process are processes that cancels each other's effect, then we have 5 minus 2 times the square root of 3 as the simplified form of the given number. And the second number, 43 plus 24 times the square root of 3. So again, think of the perfect squares smaller than 43. And among this, we have 16. And then notice that 27 is 9 times 3, and 9 is a perfect square. So therefore, this is the correct choice for splitting 43. We have 16 plus 27 plus 24 square root of 3. And it turns out that this number written in this new form is the square of 4 plus 3 times the square root of 3. And so the final answer is 4 plus 3 times the square root of 3. So therefore, adding the two results, the final answer is 9 plus square root of 3 for the first simplification problem. And the second, we have the square root of 88 minus 18 plus 7 times the square root of 7. Again, think of all the possible perfect squares smaller than 88. And since the radical is 7, and 7 is 1 times 7, and 1 is a perfect square, 81 is also a perfect square. So this satisfies our condition that 88 should be written as the sum of a perfect square and a square multiple of the second radicand. So it turns out that this number is the square of 9 minus square root of 7. And so the final answer, no, not yet the final answer. The simplified form of the first irrational number is 9 minus square root of 7. And the second number is 4 minus square root of 7. So adding the two results, we have 5. This suggests that integers can be disguised using irrational numbers of the form square root of a plus or minus b times the square root of q plus or minus square root of c plus or minus d times the square root of q. Using the answer 2 plus 3 square root of 5, let us do some quick construction of two specific exercises. One is, okay, and then, so this is now our simplification problem, whose final answer should be 2 plus 3 square root of 5. Another construction, okay, again the final answer is 2 plus 3 square root of 5. So we do this, we write 2 plus 3 square root of 5 as 7 plus square root of 5 minus the quantity 5 minus 2 square root of 5. And so using the squaring and the square root process or procedure or operation, so we have this simplification problem, square root of 54 plus 14 square root of 5 minus square root of 45 minus minus 20 square root of 5, whose answer should be 2 plus 3 square root of 5. During the construction process, care must be taken to ensure that both the factors a minus b square root of z and c minus d square root of z, when they appear, they should be positive. Now, if a minus b times the square root of z is negative, then use b times the square root of z minus a instead and change the sign preceding it. This would necessitate some readjustment on the supposed answer. That is all for now. We hope that you have learned something new, interesting, or useful. The next two videos will be about the 3-point form equation of a parabola. God bless.